Hello, my name is Rick Robinson. I am the Division Vice President at Vision Research and in charge of marketing. The parent company of Vision Research, called Photographic Analysis, was started in the 1950s. It was a business that was primarily focused on delivering services around high-speed film acquisition. So it was consulting, service delivery, those sorts of things. And then in the late 1990s, some of the children of the original founders of the company saw the transformation coming from film to digital. And they decided to start a daughter company, if you will, that would focus on the digital acquisition at high speed. And that was the birth of Vision Research. We're very vertically integrated as a company. We design our own high-speed sensors. We design all of the internals to the cameras, all of the electronics. We've written all of the software, and we provide the software that runs on a PC that basically drives the camera and gives you a user interface to it. We pretty much own the entire value chain with respect to how the camera gets designed and developed. What I found fascinating about high-speed digital cameras is that they really are another piece of test and measurement equipment. I mean, they give you both a qualitative analysis of a high-speed event and, if you combine it with motion analysis software, a qualitative picture of what's going on. You can actually make physical measurements from the images that you acquire. Yet, it's got applications that go way beyond that. Because of the slow motion footage, the cameras have become quite popular in, obviously, sports, or in making television commercials or special effects for movies, etc. So that's a part of the industry that's new to me and one of the more exciting parts to learn about. When you think about a digital high-speed camera, you can really think of it like a digital SLR, where you're pushing the button a million times per second, okay? So it really is just taking still images. It's just taking them very, very quickly and then loading them into the memory of the camera very, very quickly. Now, each time you take one of those pictures, there's two types of exposure that are occurring. One is the exposure that's allowed by the lens setting, so it's how much light is coming in through the lens, all right? Now, in a digital SLR, there's usually a mechanical shutter that opens, lets that light in, and then closes. On many modern cameras, that shutter can stay open as short as 1/1000th of a second. We don't have that kind of shutter on the high-speed digital cameras. Instead, what we're doing is we're using an electronic shutter. In other words, we send a signal to the sensor that says start acquiring photons, and then we send a signal to the sensor that says stop acquiring photons. And it's that period between start and stop that's the equivalent to that mechanical shutter on a digital SLR. So the way the sensors are designed for high speed is they have a certain throughput. You can get a certain number of pixels per second off of that sensor. We have sensors that can run at 1 gigapixel per second, 2, 4, 6, okay, 7 gigapixels per second. So when we design the sensor design determines what's the maximum throughput, all right, in just pixels per second. So then if you have an image with a lot of pixels, then you're going to be able to run at a certain rate. As you reduce the number of pixels that you're acquiring, then you can run at higher rates because, again, it's all a matter of how much you can take off the sensor at any given time in pixels. There's several things that go into the form factor of the camera. One is there's a certain amount of electronics that's required. So what's going to be the form factor of that electronics, and then the camera is built around that. We also have to think about things like cooling. You know, the physical design of the camera has to be such that we can cool it adequately, because when it's running at very high speeds, it does generate some heat. We were getting customer feedback that that particular size on the V-Series cameras was an impediment to its use in certain applications. So that's what led us to the design of the Miro. The electronics is stacked in this camera this way. We run it off of a battery, which is in here. We can save the movies to a compact flash card, which is here, and you can even program the camera, take movies, preview movies on a LCD screen on the back of the camera. So because this is lighter, smaller, and completely untethered, it's seen a tremendous amount of use in applications where our other cameras might not have worked very well. In terms of deciding what features go in a camera, whether the 1,000,000 frames per second is important or whatever, obviously we like to hear back from our customers or our prospective customers about what their applications are, what their needs are, what their current struggles are, what their frustrations might be. But at the same time, we have a bright group of people here who are thinking around the corner. You know, what's going to be the next thing our customers are likely to be asking for based on the trends that are occurring in our industry. And so we kind of pour a little of each of those into the idea bucket, and out the bottom of that comes the definition of future cameras. 2009 is going to be our best year ever for new product introductions. One product that we introduced earlier this year is called the Cine Station. A Cine Station is really a docking station for memory modules that you can plug onto the camera. So you've got a memory module which is called a CineMag. That plugs onto the top of the camera, and you can record into that. And they come in a couple of sizes, 256 gigabytes and 512 gigabytes. The thing about the Cine Station is you can take that off the camera and drop it on the Cine Station, and it's like a docking station connected to your computer, where you can now view the movies that you've taken, trim them, clip them if you need to, play them out over video, or download them to a disk where you then might do motion analysis on them or some kind of post-production or something. Over gigabit Ethernet, those downloads could take 8 or 9 hours because it's just a tremendous amount of data. So we've recently introduced a Cine Station with 10 gigabit Ethernet on it. So now instead of 8 or 9 hours to download a full CineMag worth of footage, you can do it in an hour or maybe just slightly over an hour. Huge productivity improvement for our customers. Another product that we introduced this year that's actually turning out to be a very popular product is what we call the V310. It's a 1 megapixel camera that has a 3 gigapixel per second throughput. So that means at 1280 by 800, which is its native large resolution, it can take about 3,000 pictures per second. It's really kind of a little brother of the V12 one, and it's become a very popular camera for us because it has the performance people need and at a price point that's very attractive. We also have introduced a product called the V640. It is a 4 megapixel camera, 2560 by 1600, and then it can run at a throughput of 6 gigapixels per second. So it's very fast, it's large resolution, and it also has extremely good light sensitivity. Those are the 3 products that we've introduced so far this year. All I can say is that's only the beginning. Being located in New Jersey is extremely helpful to us, and I think being in the high-speed camera business, I can't imagine another place that you'd be better located. There's lensing vendors and representatives in the area. There's plenty of people who can help us with our mechanical designs. There's consultants and experts in the electrical design side. Many of our customers are in this area, whether they're pharmaceuticals, whether they're military test ranges, whether they're universities and research laboratories. New York is certainly a great market for the entertainment applications, and it's a great place to live and work. So New Jersey's been good for the company. It's been a lot of fun for me too.